Hey everyone, how has this niche concept of reinforcement learning in the past really only applied to robotics and simulation has transformed the NLP space? So again, I'm Thomas Joshi. I'm an ML researcher here at Stanford. The point of this series is to give you what you need to talk about artificial intelligence in a job interview or with your customers or with a client. Um, Today we're going to be talking about a post by Chip. So she's a former Stanford researcher and NVIDIA engineer, turned ML founder. And she's my favorite voice in ML engineering right now. And she wrote up an extensive explanation of reinforcement learning from human feedback. And so what we want to go into today is how should you explain that to others? What are the kind of three key components of that? Pre-training for completion, phase two, supervised fine-tuning for dialogue, and the final step, reinforcement learning from human feedback. So to get into it, the first part, pre-training for completion, right? So we have a language model, and we can think of this as a completion machine. So given a text or prompt, it can generate a response to complete that text. And so an example would be the prompt, the weather is, the completion is sunny. And so many tasks can be framed as completion tasks: translation, summarization, writing code, doing math. And so to train a language model for completion, you feed a lot of text, and it can understand the language from training on that text. And one of the key problems here is the data bottleneck. So someone might wonder, how much is a lot of data to train these models? Well, today for a language model like GPT-4, you use so much data that there's a realistic concern we'll run out of internet data to train on in a few years. And the reason why that is because the rate of training data size growth is much faster than the rate of new data being generated. So once that publicly available data is exhausted, I think people really believe that this will transition into enterprise data, so unstructured text in the form of PDFs, PowerPoints, and the documentation. Okay, so we've talked about that first phase, pre-training for. The second phase is phase two, supervised fine-tuning for dialogue. And so first of all, PyTorch has great tutorials on fine-tuning large models, so I'd highly recommend them. But to give you a high-level overview, supervised fine-tuning it's showing our language model examples of how to appropriately respond to prompts of different use cases. So you could do question answering, summarization, translation. And the examples follow the format: prompt, response. And those are called demonstration data. So demonstration data, that can be generated by humans, like what OpenAI did with InstructGPT and ChatGPT. And so that's that second part, the phase two, which is supervised fine-tuning for dialogue. And the final part is the RLHF, the reinforcement learning from humans. So to give some background here, that improves performance significantly compared to specific fine-tuning. And the key problem is you have the demonstration data that tells the model what responses are plausible for given context, but doesn't tell the model how good or bad a response is. And so the solution to solve for that is, what if we have a scoring function that, if given a prompt and a response, outputs a score for how good that response actually is. And so then we use a scoring function to further train a large language model towards giving responses with high scores. And so the way we do that is we train a reward model to act as a scoring function. And in the second step, we optimize the language model to generate responses for which the reward model will give high scores. So we've talked about this reward model in the scheme of the second phase, of the third phase, which is RLHF. So what is the reward model? Well, that reward model's job is to output a score for a pair of prompt and response. So the problem we're trying to solve for is, with the challenge with training a reward model is obtaining trustworthy data. So getting different labelers to give the consistent scores for the same response turns out to be very difficult. And the way we solve for that is, it's a lot easier to ask labelers to compare just two responses instead and decide which one is better. And so for InstructGPT, the objective is to maximize the difference in score between the winning response and the losing response. And people have experimented with different ways to initialize this reward model. You could try implementing that from scratch, or starting with the specific fine-tuned model as a starting point. And it turns out starting from the specific fine-tuned model, the SFT model, seems to give better performance. And the intuition is that the reward model should be at least as powerful as the LLM to be able to score the LLM's response as well. Okay, and so we have this reward model. What do we do with that? Well, Now we're fine-tuning using the reward model. So further train the specific fine-tuning model to generate output responses that maximize the scores by the reward model. Okay, so how do people do that mostly today is through PPO, proximal policy optimization. So that's a reinforcement learning algorithm we can get into in a later date. That was released by OpenAI. And so prompts are randomly selected among customer prompts. So then the next step is each of these prompts is input into the LM model to get back a response. And then finally, that's given a score by the reward model. And just to the last step I want to touch upon is RLHF and hallucination. So there's a couple hypotheses that Chip goes into in the article about why LMs hallucinate. One is the lack of understanding of cause and effect, right? So humans at birth are given this causal understanding that one event causes another, and we seem to have these forms almost set at birth, or at least we learn it when we're young. And the second hypothesis for why LLMs hallucinate is caused by the mismatch between what the LLM, that understanding, and the labeler's internal understanding. So our view of the world as humans versus the LLM's view. So that's a summary of the third phase, which is this is the actual RLHF process, the background on the reward model, why do we do it, and then what are some issues with hallucination. So the so just to summarize of kind of what we talked about, you have the three key phases, right? So you have the first phase, that's pre-training for completion. Okay, that includes we talked about the language model, what are the data bottleneck, and then we get into the phase two, which is supervised fine tuning. Okay, talk about what that is. We talk about demonstration data, and then the final step, which is RLHF. Why does it work? What goes into that? What is the reward model? And so that's the kind of the three-step process that goes into an RHF system. So um, that's a recap of the article. Definitely highly recommend the mathematical explanations in the original article as well that you should go into. Comment below what you think is some key strengths and key weaknesses with RLHF and what we'd want to look into